Hi, my name is Puneeth and welcome to my channel Everyday Space. In today's video, we're going to be talking about India's Gaganyaan mission, where India will send crews of astronauts into space on their own launch vehicle and capsule. We're going to be simulating this in a game called KSP, which I showed you in my previous video, so be sure to check out my previous video before watching this one. So KSP is one of the best softwares for rocket launches and rocket missions in the world. This is why we're going to be using it today. Just to make sure, Gaganyaan is one of Isro's most prestigious projects in the works. India has been spending a lot of time researching how to send humans successfully into space and bring them back. So let's get started. So here you're going to see the launch of the GSLV rocket with the astronauts on board. The two S-200 solid rocket boosters just ignited and are gonna send the astronauts to mid-orbit. So as you can see, we fast forward a bit there, and now we are almost exiting the atmosphere. We are continuing to gain speed as we exit. So now you can see things are starting to get heated as the rocket is now exiting the atmosphere. The S-200 solid rocket boosters are almost out of fuel, and we're gonna detach them shortly. The center core stage engines have already ignited and are continuing to boost the rocket. So that is the S-200 solid rocket boosters running out of fuel. And now there you see, the S-200 solid rocket boosters are separating away from the core stage of the GSLV Mark III rocket. So the core stage is going to continue to make fine corrections in their orbit to send the astronauts fully into a circular orbit around 600,000 meters above the surface of the Earth. We are continuing to raise the orbit with the core stage of the rocket. So now we're about to separate the rocket away, and we're going to continue to boost the periapsis. We are not in orbit yet, and we are going to fall back to Earth if we don't do anything. This is why we're going to boost our orbit even higher to make it circular and make sure it is round enough for the second stage to make the fine corrections. So we're continuing to boost up our orbit. So we are now in orbit, but it's not very circular, so we're going to leave that to the second stage to make fine orbital corrections. So now you can see we separated the core stage of the rocket from the second stage of the GSLV rocket. This is one of the main events that happened during the launch sequence. Now that the first stage has now separated, the second stage of this rocket is going to send astronauts in a perfectly circular orbit of around 600,000 meters. So this rocket also has solar panels on board for the electricity that require the astronauts to live. So we're still making final orbital corrections as we need a perfectly circular orbit when sending astronauts to space. So we just turned the lights on of the crew capsule. We are continuing to raise our periapsis and apsis to make a circular orbit. So then after it is a circular orbit, we can then detach the second stage from the crew module, where the astronauts are. So we want to get almost a perfectly circular orbit just to make sure that the onboard thrusters don't have to do that much. We are now preparing for separation of the crew module because we are in an almost circular orbit. We're continuing to make fine corrections. Now we are super close to 600,000 meters on both of them. So now we can separate the capsule. Okay, it has now officially separated the second stage from the crew module. We are currently focusing on the second stage, but eventually we will switch on over to the crew module. So now that this second stage is going to burn up in the atmosphere eventually, and now we switched over to the crew module of the spacecraft. So the crew module is continuing to orbit around Earth. And as you may see here, you might see two sections of the spacecraft. The top section where you see the lights is the crew module, where the crew is going to be, and the other section where you see the solar panels and radiators is where most of the oxygen and the fuel supply is for the spacecraft. And you also have two onboard thrusters for the deorbit burn. There. We are now deorbiting the orbit now that the astronauts have spent almost a week in orbit. We're going to continue to ignite these engines until the orbit is now not officially in orbit, and we're going to eventually deorbit. As you can see, it is not a perfectly circular orbit now because we lowered our orbit enough, so we will now go back to Earth. So as you can see, we are very close to Earth, as we can now see it. We are also igniting those two engines to slow down our velocity so our parachute can have less much of a job to do. By doing this, we are ensuring that we are not entering the atmosphere too fast so that the re-entry will not be so intense. We are going to keep on ignite these until slow down our spacecraft. There. Our liquid fuel is almost diminished, and we have slowed down our orbit a lot. And now there it is, separation. The service module of the spacecraft is separated from the crew module. This is done so that the crew module can now expose its heat shield at the bottom of the spacecraft. The service module will then deorbit in the atmosphere because it does not have a heat shield at the bottom to prevent it from heating up in the atmosphere. So there it is. We have fast forwarded a bit, and we are now re-entering the atmosphere. The heating is going to get the most intense on the entire launch sequence because we are now re-entering the atmosphere at speeds more than 1,500 meters per second. The atmosphere will slow down our spacecraft by a large margin because the air will eventually stop it from being so fast. We have now entered the atmosphere again, and the re-entry sequence is over. We are now going to eventually deploy the parachute to slow our spacecraft down even the final 100 meters per second. We have now deployed the main parachute of the spacecraft to slow it down even more. It is only partially deployed and not fully deployed, and it will fully deploy shortly when it's closer to the ground. There it is. We see it getting fully deployed. And now it's going to be a smooth descent down to the surface because we are only going at 8 meters per second. We are getting really close to the surface of the water, and the astronauts are almost back to Earth. So they have officially completed the in-orbit journey and have now finally came back. Isro will probably send boats and rescue teams to bring these astronauts back to Earth. So thanks for watching, and if you want to watch more of my videos, please subscribe and like. In this video, we saw how the Gaganyaan mission will take place and how it will end. And be sure to check out my future KSP videos in the future. So thanks for watching.